So hello guys, today in this video I am going to show the main animation of motion of double pendulum using GUI in MATLAB. So basically the three scripts you are seeing here are responsible for the above animation, means the animation that I will be showing to you within some minutes after. But let's first know actually what double pendulum is, means what's the mechanism of double pendulum. It's nothing but these two pendulum, right? These two pendulums are attached to each other as well as a fixed point, and the two strings are assumed to be inextensible, having lengths L1 and L2, and initially say they are inclined at theta 1 and theta 2 respectively, and these are having m1 m2 masses, these bobs having into m1 m masses, and so the position of bob m1 is nothing but L1 sin 1, and y1 is the cos component generally, and x2 is nothing but the summation of these two distances that we are having. So this is nothing but the L1 sin theta plus L2 sin theta 2, and y2 is nothing but the opposite here. Y2 is taking up the means the the distance of m1 takes up the distance of L2 in, means m2 in downwards component, right? So it's actually it's both are additive, but it's in the negative direction, so minus of L1 cos theta 1 plus L2 cos theta 2, right? So now, having all these terms, we generally define the potential energy and the kinetic energy of this same, and so the Langrangian is nothing but T minus phi, which is nothing but this expression that we get, and the theta 1 is means the Langrangian operation we know, like Langrangian operation, uh, Langrangian operation, like Langrangian operation is nothing but this one, right? Langrangian operation is nothing but this one. So dou d by dt into dou L by dou Q dot minus dou L by dou Q equals to 0. Here Q is nothing but the theta term here, right? So the image is not loading properly. So let us try for see that is yeah, here we see first we define the concept, means the potential energy E and kinetic energy T, and so we are having the Lagrangian is nothing but T minus V, and gradually, since the partial derivative of any, means the potential energy has actually no relation basically. Maybe there is relation, means it this is not properly written, but let me show another one, like this one, right? So uh, this one is nothing but means the same one. Okay, the main concern is here that d dt by dou L by dou x dot minus dou L by dou x should be equal to 0. Okay, should be equal to 0. Okay, for conservative field, means if all of them are perfectly defining the kinetic energy as well as the potential energy, and the energy is conservative here, anyways no energy, other energy is providing to the system, then this should be equals to 0. El should be equal to 0 here. Okay, so that's the same operation here done, that is done, and theta means here, means the x dot should be replaced with theta 1 dot and theta 2 dot, so that we obtain the values, the essential values like theta 1 and theta 2, means theta 1 and theta 2, and basically we can construct motion of this pendulum, double pendulum, right? So after that we move on to this code. Basically I have done the same way, I have done in the same way. Actually there are means I have defined a matrix ZD, where it has the Z3 is nothing but this one actually, and Z3 is actually theta 1, Z3 actually theta 1, sorry, theta 1 dot, Z4 is theta 2 dot, and Z1 and Z2 are theta 1 and theta 2. So and zt means z derivative basically. So z1 is nothing but means zd1 should be what, theta 1 dot here, right? So theta 1 dot is nothing but z3, right? So I have written in this way, and z4 is this one, and theta 1 double dot is obtained using Langrangian mechanics, and we are having this equation. I have simplified using another you know another basically let me show you the Langrangian one. uh, where is that? uh, Basic GUI, not basic D pendulum, no D pendulum, basic like this one I guess. Not this one actually, not this one actually, but anyways, actually it was kind of derived using a simplified expression, rather means it was a complex, it means it was solved using the Lagrangian mechanics itself. But actually I am not getting the file, actually it's deleted somehow, I didn't notice. So this is the thing. And after deriving the z derivative, okay, and I have the theta 1 naught, theta 2 naught means initial conditions of theta, thetas and acceleration means angular acceleration. So means angular acceleration, angular velocity actually, theta 1 dot is angular velocity here, both are 0, theta 1 dot and theta 2 dot are both 0. So and initial values are having theta 1, theta 2, theta 1 dot and theta 2 dot, right? And time span I have taken from 0 to 100 seconds. And so it's the ODE function basically which is solving the motion of this double pendulum. What should be the x comma means x y coordinate of both the bobs moving, and it is storing in variable z, where z is having theta 1, theta 2, theta 1 dot and theta 2 dot, right? So and x1 can be written in terms of theta 1 and theta 2, means x1 y1 x2 y2 can be written in theta 1 and theta 2, right? In this manner as we have seen. So after deriving this, we have, now I have written the GUI of that. So basically it's plotting will be happening after some initial declaration of values, like I have not declared L1 L2 M2 G and L2. So basically I will be declaring in the GUI itself. I can also declare the initial conditions too, but I have actually ran out of time and didn't do that. So anyways, so here mass parameters, let's say I am giving 1 and here 1.5, say 1.5 here, and length is something 1 meter and this is 2 meter, right? Now I click on plot. So it's, and see, and let's increase the mass of M2 to something like 10 kilos to check the actual whether it's actually FA means the mass is having a role on this, right? So see, as I have increased the, see, let's say we have declared to C, and yeah, it's kind of very means it's very interesting to see this. And G is 9.8 meter per second, so I have declared. And so thank you guys for watching. So thanks.